we are going to learn about scientific notation. Today we are learning something new. It's not the hardest kind. You'll get the hang of it later in the video. So, first off, we're going to learn the definition of standard notation, which is just a very basic number, like 2,300,000. You see, this is standard notation. Standard notation basically means a regular number. But, do you see, you can use scientific notation on very big numbers or very small numbers as well. So, for example, let's say I didn't want to write this down. And so I could just say, first you write some kind of decimal. Since there's all zeros here, but here there's no zeros, I write 2.3, 2.3. So, and we multiple, not 5, since it goes up to the millions. How many spots before you get to 2 are there? 1, 2, 3, 4, 5, 6. So here's what you're supposed to write. 10 power of positive 6. So here's some more examples of some. So I told you that scientific notation can be a very big or very small. I can show you what I mean by that. So we had 7.4 multiple 10 power of 9. So you see, this equals a very big number. It equals, I'll write it down first. So this is a very big number. And to check, if you want to see if the number is correct, 7 and 4, check. And 9, 1, 2, 3, 4, 3, 6, 9. Correct. But remember, it can be a very small number as well. What if I did 7.4 multiple 10 power of negative 9? That would be a very small number. I can show you what it looks like. It's 0.00000. Since it's power of 9 and there's 1 0 here, literally 8 zeros here. 3, 4. And just to make sure, 1, 2, 3, 4, 5, 6, 7, 8, 9. So what's 3, 6, 9? This is a very small number. Well, this is a very big number. So we worked on moving numbers from standard notation to scientific notation, but now we're going to work on moving scientific notation to standard notation. So if an exponent on the 10 is positive, move the decimal that many spaces to the right. If an exponent on the 10 is negative, move the decimal that many spaces to the left. 8.91 multiple 10 power of positive 7. That means the decimal is going to move this way, not this way. So I'm going to write an equal sign. So this is going to move 7 spaces, and the 8, 9, and 1, they'll just stay. 8, 9, 1, just like this. 0, 0, and thousandths mark. 0, 0, 0. So this is what you get if you do positive, but what happens if you do negative? Well, remember what happened when I was showing you some rules? Basically, it just turns into a regular number, and then there's a lot of zeros. So, what about 4.667 multiple 10 power of negative 6. So equals, this decimal will move all the way this way. So it equals 0.000000 and 4, 6, 6, 7. This is what happens. So here's what happens. So when you get positive, there'll be that many digits behind a certain number. And when it's negative, there's a 0.0000, however many you need to do, and then just follow up with numbers. The same numbers from here. So I'm going to give you more details now. To convert a positive number from standard notation to scientific notation, count how many places you have to move the decimal point so that there is only a number between 1 and 10 that remains. The number of spaces that you move the decimal point is related to the exponent of 10. I'm going to show another example. It's converting 3,320,000 and it's converting 3,320,000 320,000 to scientific notation. So what we're supposed to do is, you see, we have millions. So I know we see these numbers, so I'm going to mark these up. We're supposed to write this as, for the scientific notation, I'm supposed to write 3.32. So I'll take this out now. Because remember, since it's a full number, you have to multiply it by some kind of power, so this will move back. Now, we have millions, so how many digits will be behind? 6. 1, 2, 3, 4, 5, 6. So it's multiple 10 power of 6. No matter what you do, it's always 10. If the standard notation is less than 1, the exponent of 10 will be negative. Now we're used to converting numbers like these but into scientific notation, but now we're going to do a decimal back into scientific notation. So we're doing 0.00724. Do this. Now remember, it's always like one number point some other number. I'm going to move this point over here. And since there's 4 zeros, it's 10 power of, remember, it's not this, so it's negative 4. So we're writing it down. Equals 7.274. Multiple 10 power of negative 4. Because that's the amount of zeros.